पुनीता। कहो नानक जाके वड भागा, बिन जन्म पदारथ जीता।
So in this display, we want to stress on what is black body radiation problem. Around 300 years back, it was the matter of discussion among the scientists that what is light. According to Newton, light consists of particles and the name corpuscles was given to those particles of light as per Newton. And Newton's contemporary scientist Huygens proposed the wave theory of light. There was a conflict among the two. Huygens wanted to say that light is a wave and Newton wanted to say they are particles. Question is, what is wave? Please see, wave is a disturbance which is caused by the periodic motion of the medium particles. Like for example, we want to say that when Turing fork is plugged, then the wave, that is the layers are compressed and rarefied, and thus the compression and rarefaction is proceeding, not the particles. The particles are executing only to and fro motion, that is periodically they are making SHM. So what is proceeding in fact? The disturbance, not the particles. So therefore there was a conflict between Huygens and Newton. Newton wanted to say light is consistent of particles and Huygens wanted to say it is a wave phenomena. Gradually the diffraction, polarization and interference came in. These experiments had shown that light is a wave phenomena. In 1802, with the discovery of interference by Thomas Young, it was proved beyond doubt that light is wave phenomena because on projecting light from single source and it split into two, we had seen the black fringes and the bright fringes. With the observation of bright and dark fringes, we understood that when interference was destructive, light was zero at that place, that is dark fringes, and when light was constructive interference, it was bright fringe. So with the interference being constructive, bright fringe is obtained, and when the destructive interference occurs, dark fringe is obtained. And therefore it should be clear that with the discovery of interference particularly, that light is a wave phenomena and the Newton's corpuscular theory was buried is a fact of the day. Now we follow Stephen Boltzmann's law. It will be felt that we have shifted to heat for the time being. What is Stephen Boltzmann's law? Stephen E equal to alpha times T to the power 4 minus T0 to the power 4. That is E equal to alpha times T to the power 4 minus T0 to the power 4. This law was discovered by Stephen practically and by Boltzmann theoretically. Now we understand Wien displacement law. Lambda T equal to constant. With this law, what do we understand? It is pertinent to follow that the Stephen Boltzmann's law is applicable on perfect black bodies. Similarly, Wien displacement law is again applicable only on perfect black body. According to this law, when the temperature of perfect black body is gradually increased, the wavelength corresponding to maximum energy emission gradually goes on decreasing with the rise of temperature. So we understand lambda m equal to k by t. It means what? That it is clear from this formula, with the increase of temperature, the wavelength will decrease. As such, that lambda v is less than lambda indigo, lambda blue and then lambda red. Thereby, with the increase of temperature, the color of emitted light will shift from red towards violet region. Now we have seen Stephen Boltzmann's law, the relation between E and T. Wien displacement law, the relation between lambda and T. Therefore, some mathematicians, some scientists must come up with E lambda and T relation. And they were Lord Rayleigh and Sir James Jean. Please understand, Lord Rayleigh and Sir James Jean gave an equation connecting E lambda and T. So connecting E lambda and T, E equal to 8 pi kt lambda power minus 4 was given by Lord Rayleigh and Sir James Jean. We understand that the practical graph and the Rayleigh graph both differed. Number of scientists wanted to explain the difference in the graph and they wanted to understand some mistake should be there in the Lord Rayleigh equation. But as a result, number of mathematicians who tried on this problem, they came to the solution that Lord Rayleigh and James Jean equation was errorless. Then why is the difference in the graph? This sort of question arose in the field of science, perfect black body radiation problem. To show that why is the difference in the graph, Max Planck tried on this problem and he thought to give correct equation pertaining to practical graph, and he obtained the graph as follows. Planck equation turned out to be E lambda equal to 8 pi nu h lambda power minus 4 upon e to the power nu h upon kt minus 1. This equation is although little ahead than 12th class, but the better students of IIT will need this equation to be understood. The equation E lambda equal to 8 pi nu h lambda power minus 4 upon e to the power nu h upon kt minus 1 says what? When E equal to h nu, that is when we take energy epsilon E equal to h nu, it is tending to 0, then the equation returns back to 8 pi kt lambda power minus 4. That is Lord Rayleigh's or James Jean equation is turning back. Therefore, if we want that the Lord Rayleigh equation should not come back, then we are bound to say that E equal to h nu should not tend to 0. Means what? The Planck theory of radiation come up, energy whether in any form, it is never continuous and it can transmit only in terms of any integral multiple of h nu. In other words, h nu is the smallest unit or packet of energy. The Planck equation was given by Max Planck on 14 December exactly 1900. But since that day when Planck gave this equation, he was severely disturbed till 1911 with respect to the equation E equal to h nu. Even though Planck was very happy to note the Einstein's explanation on photoelectric effect in 1905. That is, photoelectric effect was discovered in 1905, and Max Planck, when he saw this equation due to Einstein, he was very much happy. The reason was that E equal to h nu prevailed everywhere in the explanation. And then only between 1900 to 2000, that is only in 100 years, the physics developed is around 1000 times that developed between 1600 to 1900, that is in 300 years. The whole credit will go to E equal to h nu. That is, we want to say that E equal to h nu was found to be a solution of black body radiation problem. Max Planck gave E equal to h nu as a solution to black body radiation problem. Now we go ahead please. Now in the sequence with the development of E equal to mc square, that is E equal to mc square equal to h nu. We cannot avoid h nu now. So m equal to h nu by c square. We want to say energy consists of particles according to E equal to mc square, but E equal to mc square is equal to h nu, and therefore we say m equal to h nu by c square. Now the question is, does energy consist of particles? Yes. Then what about light? It is energy, and therefore we want to say if light is a particle, then is it not a wave? It's a very curious conflict. We want to see that if it is a particle, is it not a wave? If not a wave, then what about Young's interference? So again, if light is particle, is it not a wave? If it is a wave, then is it not a particle? But we cannot say now that it is not particle. Then the question arises, is it not a wave? If it is not a wave, then what about Young interference? Why we obtain black fringes? Black fringes appearance says that light is wave in nature. Therefore, the situation arises, neither we can leave light as a particle, that is energy being particle, light is a particle, and light is a wave. We cannot leave this fact because in the light of interference, Young interference, especially dark fringes. Then we are again back to the question back in 1900, which is started almost in the mid of 1880. What is light? And now we are back with the question, what is light? The question is back, what is light? Light is a wave or a particle? Now the question is, neither we can leave the particles nor the wave, then what it is? Then some situation must come out which should say both, and that was done by Louis de Broglie. Therefore, the solution of historical problem was given by Louis de Broglie by hypothecating the concept of matter waves or pilot waves, for which he was awarded Nobel Prize in the year 1924, as I know. May be wrong. Now question arises, what is matter wave? What is pilot wave? It is apparent that neither the concept of Max Planck could be left, that is light is a particle because it is an energy, nor we could reject the concept of a wave because of the interference, that is destructive interference given by Young. Neither we can leave Young experiment, nor we can leave the energy as particles, therefore light should be energy. Therefore the solution merges out in the form of dual nature of light. As we see on the screen, when white solar light is fallen on prism, the different rays which are coming out, ultraviolet to violet, and even apart from that, cosmic, gamma, X, and then ultraviolet, violet to red, infrared, radio waves. Then these are the waves on the top of which the cosmic photon, we will say cosmic photon, that is particle of light is sitting on the top of the gamma rays, gamma photon, X photon, violet photon, red photon. These are sitting on the top of the wave and the wave is carrying them. And therefore this understanding will suggest us the dual nature of light. How is dual nature of light? Pilot wave, according to Louis in general, when any particle moves with a velocity v, for example, wave is associated with the particle. The wave is like this, as if the wave is carrying the particle. So is the name pilot wave. Now, for amusement, what is telepathy, and how do pilot waves help to understand telepathy? Telepathy, what is that? Very fine thing have been told. Suppose I say very fine thing have been told. Then very means some energy have been dissipated. Fine thing have been told. When we say like this, some energy is coming out from the mind. And with this energy, what is happening? Louis de Broglie wave says what? So with the emission of this energy from the mind, we will say some wave is associated, which we have just spoken as pilot wave. And this wave, what we have spoken about, will tell us if someone understands about this wave. Very fine things have been told. So we understand pilot wave, the equation is m equal to h upon v into lambda, or otherwise lambda equal to h upon mv. With this equation, what do we understand? Very fine things have been told. Some energy is liberated. And with the energy liberation, a particle is associated with this energy. And thus, with the help of this wave, if one can understand this wave, then he can understand what has been thought. Very fine thing have been told. Now, we should know whether this telepathic knowledge does prevail on earth. Is there anyone who knows about this knowledge? So therefore, I want to say that I know at least one person in Jabalpur itself, Mr. M.D. Dubey, retired engineer of MPEB Jabalpur, who is well aware of telepathic knowledge. I can definitely let Mr. Dubey meet anyone who wants to ask whether this knowledge prevails or not. I know this person very well and I have seen the venture produced by Mr. M.D. Dubey before me. So we have understood that light is energy and therefore energy is particle. This particle of light will be called photons. The question is, who gave the name photon and why the name photon is very good one? See, we are going little back. A better name photon have been given to the particles of light, which means photograph carrying particles. It's a great amusement to understand that the particles of light have been named as photons, means photograph carrying particles. So does they carry photograph? Of course, yes. I want to say that you see anything, like you are observing my picture on the screen. Then the question is, how you are able to see my picture on the screen? When light is on my picture, it has carried the photographs and you are able to see it. That is, whenever light falls on a body, it carries its photograph. Therefore the name photograph carrying particles, photons. It's a matter of observation that whenever we see anything, we are able to see why. Because when light has fallen on the body, it has carried the photograph, we have seen it, we say, like any match is going on. So we can say that when Mr. Tendulkar has hit sixer, we are able to observe on the screen. How we are able to, suppose the match is going on in England and now we are observing it here in India. How it is possible? When light has fallen on the system, it has carried photographs, and these photographs have been carried on the TV screen and we are able to observe. We take another example. We see our picture in a simple mirror. How we are able to see the picture in the mirror? It means when light has fallen on our body, it has carried the photographs, and this mirror is an instrument to see the picture. Please understand, the name photon is a very amusing one, very nice one. Now we go back to photoelectric effect. When Max Planck had discovered the equation E equal to h nu, he was worried up to 1911. Actually in 1905, with the discovery of Einstein's explanation on photoelectric effect, he was very much pleased. Before the explanation of photoelectric effect by Albert Einstein, we would like to see some incidents, observations which have been made by the scientists. We observe that for every metal, there was found minimum frequency below which the electrons could never be ejected from the metal surface. This minimum frequency was named as threshold frequency. Next is keeping the intensity constant, that is amount of light falling on the system constant. When the frequency was gradually increased, the electrons shooted out with more velocity. Next is keeping the frequency constant. When the intensity was increased, only the number of photoelectrons was affected. So very easy and a clear-cut solution was given by Albert Einstein with respect to photoelectric effect. I am giving some questions related with the aspect before going ahead with the photoelectric effect. Number one, what is work function? You should know it. You should know like anything very familiar. Not that you have to just mug up. What is electron volt? The work function of a metal is 3 eV. On projecting light of wavelength 4000 AU, the photoelectrons will eject out from the metal surface or not. So therefore, such questions please solve more and more, and then you will follow what is photoelectric effect equation. You have to solve as many problems as possible on this fact. Let E be the energy associated with the incident light, E dot be the work function of metal X. Now if E is greater than E dot, E is equal to E dot, or E is less than E dot, then H nu is greater, because if E is greater than E dot, then H nu will be greater than H nu dot, and accordingly H cancelled, nu will be greater than nu dot. If E equal to E dot, then H nu equal to H nu dot, that is nu equal to nu dot. And if E is less than E dot, then H nu is less than H dot, which means nu is less than nu dot. And therefore, we understand that if E is greater than E dot, H nu, accordingly, nu is greater than nu dot, that means electron will eject out. That is, photoelectrons will be ejected. If E equal to E dot, then in second case, nu equal to nu dot means again photoelectrons will be ejected. But if E is less than E dot, then nu will be less than nu dot means electrons will not be ejected. Now we see related questions on photoelectric effect. Please see on the screen. The questions are: number one, why threshold frequency is essential to eject the electrons from the metal surface? The question is, why threshold frequency is essential to eject the electrons from the metal surface? The answer is very apparent. The threshold frequency will supply the threshold work function energy that is required for ejection of electron from the metal surface. Now next is, we see on the screen, on increasing the frequency of incident light, why only the velocity of electrons increases? Please see further on the screen. While defining the threshold frequency, we consider minimum frequency. But while defining the threshold wavelength, we consider maximum wavelength. Why? We consider more question. The threshold wavelength of a metal surface is 4000 AU. Suppose, which of the following color will eject the electron from the metal surface? A. Green, B. Violet, C. Blue, D. None of the three. Again, we want to say the threshold wavelength of a metal surface is 4000 AU. Which of the following color will eject the electron from the metal surface? A. Green, B. Violet, C. Blue, D. None. Now, like this, these questions should be solved by the student himself, and many more questions should be solved. Only then you can say that you have learned properly. Otherwise, it is only an explanation given to you. You have heard it. If only by hearing a student becomes smart enough to understand everything, which is not possible. Solve as many numericals as possible. Only then you will be called as a student of IIT, a student of medical, a good student of 12th. Please understand, a good student of 12th doesn't mean that we should not solve many problems, and a student of IIT should only solve. IIT is nothing but clear concept of 12th itself. Now more about the facts related to the Louis de Broglie equation, and that is violet waves. That white solar light, when fallen on the screen, we observe, we understand lambda cosmic is the smallest, lambda gamma, lambda x, lambda ultraviolet, lambda violet to red, and then lambda infrared, lambda radio. Further on, nu frequency, nu cosmic is the biggest, and then nu gamma x, nu ultraviolet, nu. These things must be well known to the student, well known. Ever you should know like something which is very precious. And like this frequency, cosmic to radio, it is in the decreasing order. Nu cosmic is the biggest, gamma, nu x are in the decreasing order. Furthermore, E equal to h nu suggests E cosmic is the biggest, and then E gamma x is going on decreasing, and ultimately E radio wave is the smallest. Now about pilot waves, that is dual nature of light. We see that mass nature of the cosmic photon is biggest, and then mass nature of the photons is decreasing in up to radio waves. Now we shift to another chapter, that is prisms, dispersion, deviation of prisms. We see on the screen, when white solar light have fallen on the prism, violet to red region, ultraviolet, X-rays, and in sequence it is cosmic, the smallest, and then gamma, and then X, and then ultraviolet, and violet to red, infrared, and radio waves. Now we understand that when white solar light have fallen on a prism, it disperses into 7 colors. Why? So the equation of refraction through the prisms, we know mu equal to sin A plus delta by 2 upon sin A by 2. This equation will reduce to delta equal to A into mu minus 1 as shown on the screen, and the students should come to this proof by themselves. In some other cases, in some other display, I will show all these proofs, but not right now. Now delta equal to A into mu minus 1, which is the formula for thin prisms. The question arises, the above equation is used, that is A, delta equal to A into mu minus 1 is used for only yellow color of light, green color of light, the prism and only yellow color of light, and only for thin prisms. Now we see a question as on the screen. How can we say that the refractive index mu depends on color of light? The answer is given there itself by the phenomena of dispersion of light as delta equal to A into mu minus 1. That is, when delta is different for different colors, delta V, delta R and delta red are not equal. Therefore, it is apparent from this formula delta equal to A into mu minus 1 that mu V, mu R and mu yellow and mu R are not equal. That is, we want to say that this formula delta equal to A into mu minus 1 suggests outright that the refractive index does depend on the color of light. And therefore we have understood from the formula delta equal to A into mu minus 1, since delta V and is not equal to delta yellow, delta R, therefore mu V, mu R and mu yellow are not equal. And therefore it is apparent now that we can say that the refractive index does depend on color of light. We go ahead to understand by second example, that is by the phenomena of chromatism of light. It is also expressed that mu is different for different colors. Now the question is, what is chromatism of light? It's like a defect in the lenses. And it shows what? Please see on the screen that when white solar light has fallen on a lens, FV, FR, F will be different for different colors. That is violet, indigo, blue, green, yellow, orange, red. These colors will be focused on 7 different points of the principal axis. This colored images is called chromatism, and when white solar light falls on a lens, the 7 component colors get focused on 7 different points on the principal axis, and this phenomena, this defect is called chromatism of light. Question is, what is the reason of phenomena of chromatism? We see on the screen is again because of mu being different for different colors. The reason is shown here, 1 by f equal to mu minus 1, 1 by r1 minus 1 by r2. Please see, the student should make good labor to understand all these equations, and right at the moment these lectures have been delivered for IIT medical examination, not only 12, but the students, the proofs of these aspects may be taken up from the books, but right now we are proceeding on ahead. Now please see, 1 by f equal to mu minus 1, 1 by r1 minus 1 by r2. Since fv is not equal to fr is not equal to f, and so therefore it is clear that mu v is not equal to mu r is not equal to mu. Now we put up third example. When white solar light has fallen on a denser medium, gradually denser, increasing denser medium, what we see, the red rays are reflected very less and ultraviolet rays are reflected the most, and violet in between. That is red minimum, violet little more, ultraviolet maximum. This is explained by what? That is mu ultraviolet is greater than mu violet, is greater than mu indigo, and then up to red, and then infrared. This explains what? So ultraviolet rays are bent maximum. Therefore, the early risers receive ultraviolet rays which supply vitamin D. And this is the reason that early risers have more stronger bones. Educational environment in India, due to disrespectful, especially in the schools, is not at all good enough, and therefore the students with aptitude, they disperse away in various fields of like IAS, IPS and abroad, and therefore we don't get better teachers in the schools. How do we define a good teacher? It's a property in every good student that the one who has learned with hard work, he wants to guide others. I want to say that 2 teachers are born. If you peep into yourself and if you feel that you are a good student and you want to be in the field of education, please come ahead and join in the franchise system of our branches. If you open our branch, that is Deepika classes will share only 30% and 70% will be given to the franchise holders. I want to request that the business in the education field is worth, according to me, 2 to 3 lakh crores of rupees every year. And if you want to be a part and parcel of any good educational concern, please join Deepika classes. And 70% will be shared by the franchise holders. If you want to be in this field, you come to us. We will first train you up and bring your level to the competency of medical, engineering, IIT, but even PSC, UPSC, IAS. We deal with all these examinations. This is a very great paying job. We want to open our franchise branches in Nagpur, Jabalpur also, Jabalpur, Bhopal, Indore, Nagpur, Kolkata, Mumbai, and ahead than Bangalore. On the screen, the phone numbers are given: 98275 88952 and 810-905-1009. We will train you first. It will take us at least 3 to 4 months to give you training. Without training, we are not going to keep any teacher like this. Please, thank you very much.